All right, so we are doing 5-3 today, and in 5-3, we're solving system of equations, which is what we've been doing in this topic so far, but we're doing it with a new method called substitution. And so in 5-1, we just simply looked at equations and determined how many solutions we should have. And that was one solution, no solutions, or infinitely many. Then in 5-2, we actually didn't just say how many solutions we should have. We actually graphed them to get the actual solution. So in 5-2, we got everything in y equals mx plus b. We graphed both equations. And then if they crossed, we wrote that as an ordered pair, the point where they crossed. That was the one solution answer, an actual ordered pair. Or they were parallel lines, so the answer was no solution, or they were the same line and the answer was infinite solutions. So those are our three, and that was our jump start today. Those are our three possible outcomes when you are solving a system of equations, okay? You're either going to get an actual solution where they cross, okay? Or where they're the same, right? If you're talking about like our story problems with our kayaking or our river kayaking tours and all of that, you get one point where they're the same or where they intersect on the graph, or you get no solution because they're never going to intersect or they're never going to cost the same or be the same. Or you get infinite, meaning no matter what number you plug in for X and Y, you're always going to get the exact same number. It's going to be infinite. It means it's the exact same line, and they're going to basically on a graph lay right on top of each other and share every single point infinitely many. Okay. These are the steps to solving by solution. If you're at home watching this, or even if you're in class and you did not get all of these written down, or you can't read your own writing or whatever it might be, go to this video, pause it right here, give yourself time to write it neatly so that you can read it, because this is a long process, but it's not a difficult process. It's just very long. And so if you can use this and set it next to your paper, and when you're doing your homework, right, write the problem out on a separate sheet of paper, open your workbook to this page, and then just one step, 2 step, 3 step, just do it very methodically every time. It's not a difficult process. It's just a lengthy process. Okay. And it's easy if you don't follow the steps. It's kind of easy to get lost in the process of where you're at. All right. Okay. So I want to actually, before we jump into the example number 1 they give you, I want to do a real basic one. And the reason I want to do that is if you look at example number 1 on the next page, first of all, it's a story problem. Whoops, that's from earlier when I already worked it. First of all, it's a story problem. With story problems offer their own difficulties. And also it has decimals. And somebody worded it last class perfectly. It's not that it's harder, it's just decimals can be intimidating, right? So rather than your first kind of introduction into substitution being a story problem with decimals, which is strike 1, strike 2, as far as difficulty level, I want to back it down and just do a very basic substitution system. So if you will, just for a second, turn in your workbooks to the did you know page, or do you understand, or what? Yeah, do you understand? It's page 284. And the only reason I want to use this page is because we have room to work. Okay. And so we're going to do a problem we're going to solve a system by substitution, and I'm not even going to use this one because it's decimals. Okay. So I just want to use the blank space for right now. So the system I want to solve, and I'm going to have you write this down, is x minus 3y equals 12. And the second equation is 7x plus 3y equals 12. Okay. That's my system. That's my 2 equations. And I'm going to walk through the steps of substitution to solve this. Now, if the directions had said solve by graphing, you would have gotten both of these in y equals mx plus b, and then you would have graphed them both. But we want to do substitution. So when you're doing substitution, throw y equals mx plus b out the window. You're not going to use it at all. You don't have to have your equation in any particular form. I will tell you that half of these equations don't even use X and Y. They'll use C and A or P and R or two other variables, and it's fine. It doesn't matter because you're not graphing them. So you don't need y and x because you're not doing y equals mx plus b. Okay. So step one was to solve one of the equations for a variable. Now, here's where you have a lot of leeway. Okay. Everybody can do it differently and you'll all come out with the same answer, but there is an easy way to do it and there's a harder way to do it. I am all about doing it the easy way if possible. I could choose to solve for, and I'll highlight them as I say it. I could choose to solve for this x. I could choose to solve for this y, this x, or this y. Three of those are a lot more difficult, and one of them is super easy. The one that is by itself that kind of has a 1 in front of it, it's not there, but it's there, right? If the coefficient is a 1, especially a positive 1, it's the easiest one to solve for. And I always like to take the easy one if I can. I could solve for any of the other ones, but I'm going to get fractions and I'm going to be multiplying fractions and adding fractions, and it just gets a little difficult before it settles out, and you'll get the same answer in the end, but you just have to weave through a lot of fractions to do it. So I like no fractions. So I'm going to choose to solve for x. So I am picking to solve for x in the top equation. So to do that, I just want to move it to where x is by itself. It's a negative 3y, so I'm going to add 3y, and I'm going to add 3y over here. Okay. In doing that, minus 3y and positive 3y cancel out, leaving me with x equal, well, let me write that off to the side. Sorry, I need that space right underneath it. There we go. I'll write it off to the side here. Everything's locking up. There we go. That leaves me with x equals. Now, remember I said here, throw y equals mx plus b out the window. We didn't even solve for y. So order doesn't matter. So I've got 12 plus 3y over here. I don't care what order you write those in. It does not matter. Okay. Whereas when you're solving for y equals mx plus b, I was all about order mattered and you had to write the x value first. It doesn't matter here. Okay, so this, and you'll notice in the steps, it said solve one of the equations for a variable, and in parentheses, it said clue. That's because this right here becomes your clue, and it's your clue about x. So step two was you go into the other equation, and other is very important here. You go into the other equation and you substitute the clue in for the variable. So this was my clue about x. So I go into the other equation where there's an x and I put a parentheses. Parentheses here will save you from lots of errors. So please, please, please use them. Now I am going to rewrite that second equation, but instead of writing the letter x inside those parentheses, I'm going to put the whole clue about x from my other work. So I'm going to have 7 and then parentheses. Right? And then plus 3y, all of it stays the same. Notice I'm dropping everything down. The only thing I'm doing different is that instead of writing the letter x right here, I'm going to write my clue about x, because I know that x equals 12 plus 3y. So I'm substituting in a value for x. Now it's just solving the equation. And this takes us back to early on in the first semester. When you see parentheses, you should think what? What did you say? Okay, PEMDAS. So parentheses first. And when you see parentheses, when the 7 is touching the parentheses, what do we do with that 7? Multiply. Good. And you guys are right. PEMDAS was right? We're going to multiply that 7 into the parentheses to distribute it, because we have to get rid of parentheses first in PEMDAS. 7 times 12 is 84. 7 times 3y, it's plus plus, so it's going to be a plus 21y. And now I'm just going to drop down the rest of it because I haven't done anything with that yet. Okay, the 3y equals 12 just drops down. Now, the next step in your notes was combine like terms. Well, if you look here, you've got a 21y and a 3y. Both are together on the same side of the equation, so I'm not doing my wall and moving things around. I'm just simply saying in the basket already, I have 21 apples and 3 apples. How many apples do I have altogether? 24. So the 84 drops down. I combine 21y and 3y to 24y equals 12. Now, the next step was solve for the variable that's left. The only variable I have left in my problem is that y. I need to solve for it, which means I need to move. Now is when your wall comes in, okay? I need to get the y by itself over here because that's the particular variable I'm solving for. So I'm going to subtract 84 from both sides. And when I do that, 24y drops down. My equal sign stays right on my wall. And 72 minus 84, keep in mind the 84 is a bigger number and it's negative. So it's going to be negative 72. When the signs are different, you subtract the two numbers and take the sign of the bigger number. So 84 minus 12 is 72. It's negative 72 because the 84 is negative and it's the biggest number. Lastly, I'm going to keep getting y by itself. I'm going to divide by 24 on both sides. And I get y equals -3. Now I'm halfway home. I have part of my answer, right? I have the y value, but I still need the x value. Well, if I come back up here to this equation, right? I'm just going to rewrite it so it's a cleaner version here. So x equals 12 plus 3y, right? That was our equation from earlier. Now, what do I know about the y? I know that it equals what? So can I substitute now a -3 in for that y? So that would look like x equals 12 plus 3 parentheses. And in place of the y, I can now plug that -3 because it's part of the puzzle that I now know. I know y equals -3. And continuing to use PEMDAS, am I going to add the 12 or am I going to multiply 3 times -3? Yep. So 12 and then 3 times -3 is -9. And then 12 minus 9 is 3. Now I have my x and I have my y. I have both pieces of the puzzle. And the solution to this system of equations is 3, -3. Now, it takes a lot of work to get there. It's a lot of steps, but like I said earlier, they don't get harder. It's just sometimes it's decimals and that kind of thing. But as long as you do the same steps each time, and as you do it and you get a little bit more comfortable with it, the steps really kind of make sense in that you follow that same pattern of solving for one variable and then plug in and solve for the other variable. Okay? All right, now let's go back to that example that's earlier in the book. And it was a story problem and it was a decimal. So I kind of wanted to just go through one very basic example before I jumped into a story problem. All right. It says Gemma sells tickets at a local fair. On Saturday, she sells 800 tickets and collects a total of $7,680. How can Gemma determine the number of each type of tickets that was sold on Saturday? So it takes a little bit of information from this little thing right over here. We know that adult tickets sold for $13.50 a piece and children's tickets sold for $7.50 a piece. So we can take that information and we can say right here, okay, that's this line right here. It says children's tickets were $7.50 per children's ticket, so times C, plus $13.50 times A, so that's children's tickets times adult tickets equal a total of $7,680. Okay, that's one equation that we can get from this. The other thing it told us is that they sold a total of 800 tickets in all. So the number of adult tickets plus the number of children's tickets totaled $800. So children's tickets plus adult tickets was 800 tickets. So with the information that we were given in the story problem, we can write these two equations, okay? One of them is, the purple one is the number of tickets sold. The blue one is the number of money that was collected, okay? But with these two equations, once you have a system or you have two equations, you can solve it as a system and you can find out how many children's tickets you sold and how many adult tickets you sold, okay? So step one is to pick one of these two to be your clue or to solve for? Well, I'm definitely not picking anything in the blue equation, because if I do, I'm going to have to divide off a decimal, and I'm going to have really ugly decimals to work with at first, and I don't want to do that. So my other option is to look at the purple equation. I've got C and A. Is there one that's better than the other? Nope. Both would be easy to solve for. They both have a 1 as a coefficient, so they both would be easy to solve for. Now, the book, it went ahead and solved for C, so that's what we're going to do. Okay, so we're going to pick the purple equation, and we're going to focus in on that, and we're going to decide to solve for C. And you could just solve for A, it doesn't really matter, but we're going to follow what the book did. So that means you minus A and minus A. Micah, you got that? When I do that, the A minus A goes away there, and that's what I wanted, and I'm left with C equals 800 minus A. That is now my clue. Okay, that's my clue about C. The next step is to take that clue and substitute it into the other equation. So my other equation was 7.5C plus 13.5A equals 7680, right? This right here. This was my other equation. So what I'm going to do is where there was a C, I'm going to use parentheses, and I'm going to plug in my clue, which is right here, about C, into the place where there was a C. This is where the name substitution comes in, because I'm substituting into the other. Now, just like on that other one, you have to distribute. And 7.5 times 800 is 6,000. And 7.5 times negative A is negative 7.5A. So that's where they get that next line right here. Notice they just dropped down the 1350A, and they dropped down the equal sign, and they dropped down the 7680, because we didn't do anything with that yet. Now we're in the combine like terms step. And now they actually skip some steps here that I want to fill in the gaps. To get from here to here, they really skip a lot. And so we're going to talk about what they did. The first thing they did is they subtracted this 6,000 off of this side, because it doesn't have an A, and we want it off that side if it doesn't have an A. And we subtract 6,000 from this side. That's how they got the 1680. The other thing they did is they combined the two like terms. The negative 7.5A and the 1350A are like terms. And so we can combine those like terms. Miss Borden? Yes. All right, I'll let her know. Riley, you're leaving, so if I were you, I would go back and watch the second half of this video, okay? All right, so we've got negative 7.5A and positive 1350. And so when we combine those A's, that's where they got that 6A, okay? And then lastly, now we're ready to kind of pick up from where they were, because like I said, they skipped a lot. We're going to divide by 6 and divide by 6. And that's how we get that A equals 280. So we know that there were 280 adult tickets sold, okay? Now you go back and you take this information or this number and you plug it into the first equation. Well, what was our first equation? Our first equation was C plus A equals 800. Well, now what do we know about A? We know it equaled to what? Was it 250? Yeah, 280. We know that A equaled 280. So can we now substitute in place of the A, we can put a 280. And that's what they did here, okay? This was the first equation. C plus A equals 800. They now, in place of the A, put 280 because that's part of the puzzle we know now. And now if you minus 280 and minus 280, you get that C equals 520. So there were 280 children's tickets sold and 520 adult tickets sold, totaling that 800 total tickets sold. Okay? And we won't do it, but if we took 280, where's the original equation? Here we go. If we took 280 and plugged it in right here, and we took what was the other one? 520 and plugged it in there and multiplied it times the cost of the tickets and added it all together, we'd get 7,680 because that was the total amount of money that was collected. But you don't, unless you just want to check your answer to make sure that you're right. But if you check it up here in this equation, you should be good. Okay. All right. Any questions on that? All right, let's do the try it. And we're going to walk through this, and they give you some boxes to fill in. So they kind of decide for you. If you look at this, I wouldn't want to solve for anything in that bottom equation because I would have fractions and I don't want to mess with that. But on that top equation, the X and the Y are both perfect to solve for. Either one of them would be good. Now they start boxes for you, and they start with Y equals right here. So let's just solve for Y. That way we can follow along in the boxes. So we're going to solve for Y, which means we need to subtract X and subtract X, right? And when we do, we get Y equals 50 minus X. And again, order doesn't matter here because we're not graphing anything. So don't worry about putting it in Y equals MX plus B. That becomes our clue, right, about Y. So we're going to come over here to these boxes, and we are going to say that Y equals 50 minus X. We're going to fill in the 50 and the X. Now we're going to substitute into the other equation. The other equation was 2X plus 5Y equals 160. Well, in place of the Y, I'm going to put my clue, which was 50 minus X. And now I'm going to distribute. So 5 times 50 is 250. And 5 times negative X, now notice they already have the X here. So 5 times negative X is negative 5X. Now, they don't give you the boxes for this part. So you just have to do this part without the boxes. But we know that first we need to combine like terms. We have 2X and negative 5X. What's 2X minus 5X? What is it? Negative 3X, right? 2X, 2 minus 5 is negative 3. So 2 apples minus 5 apples is negative 3 apples. Okay, when you're combining like terms, it's just apples and apples. Now that plus 250, we didn't do anything with. And the equals 160, we didn't do anything with. And now we want to solve for X. First thing is always to add or subtract whatever's extra that we don't want. So we're going to minus, it's a plus 250. So we're going to minus 250 on both sides of the wall. That leaves us with negative 3X equals negative 90. And I'm almost solved for X. I have to divide by a negative 3 on both sides. And when I do that, I'm left with X equals 30. So there's half my answer. I know that X equals 30. Yes. From, let me do it in a different color here, or do it darker. 2X and minus 5X combined together to give you negative 3X. And if you'll put 2 minus 5 in your calculator, you'll get negative 3. You're just combining those like terms. And you're not, that's not the wall, that's not subtracting things over, that's just simply they're already together on one side of the equal sign, so they're kind of already in a basket. You just want to write them as one term instead of 2 separate terms. All right, so we have half of our answer, which is that X equals 30. So now notice the next box is they substitute for X. Well, in the equation, X plus Y equals 50, we can now put that X equals 30. So 30 plus Y equals 50. Subtract 30 and subtract 30, and we get that Y equals 20. Go ahead, Eli. So if we, since this is an X and a Y, we can write it as an ordered pair. It doesn't say you have to, but get in the habit. If it's an X and a Y, write it as an ordered pair. If it's an A and a C or a P and an R, then don't worry about writing it as an ordered pair, okay? We're not going to actually fill this in, but under this convince me, it says, how do you know which equation to choose to solve for one variable? So how do you know which equation you're going to use for step 1? What's the one thing you're really looking for, Brady? Yeah, whichever variable is going to be the easiest one to get by itself, which is always going to be the one that is already by itself, that's going to be the easiest one. Okay, so when in doubt, always pick the one that already has a positive 1 with it, if you can. That's going to be the easiest route. Okay, let's go down to example number 2. Notice this actually is very nice because we can avoid step 1. Because step 1 is get one of the equations solved for a single variable? Well, is that first equation already y equals? That y is already by itself. So we don't even have to do anything to this equation right here to make it the clue. It's already y equals 14x. Okay, so that means go to the other equation, right? And where are our two equations listed? Did we have to write them? Yeah, it looks like they wanted us to write the equations first. Seiko takes pottery classes at 2 different studios. There's a number of hours which it costs. Okay, so studio 1 is $14 per hour, all clay included. So that's why we had y equals $14 per hour. Okay, that was the one equation. The other equation is $28 per hour plus $15 for the clay. And again, anytime you see two numbers, you have to ask yourself, what's the M, what's the B? Okay, per hour, when you see that per, that's multiplication. So that means 28 per hour, or x per x. So that makes that the what? That's the slope. Good. So that's the slope. And then $15 for the clay. Right off the bat, when you walk in the door, you're going to have to buy $15 in clay. That makes that the B. So the equation for that one is total cost equals $28 per hour plus the cost of clay. Okay. So those are the two equations we need. Where do they get the 1/2? I am really confused. I know this sounds crazy because I don't know where they're getting this equation right here. Oh, that's what I get for not reading more. Bring this coupon for half off the price. There you go. Thank you. Who said that? Get you a piece of candy. It's what I get for not reading the whole thing right here. I just did what I always tell you guys not to do, which is not read it all. Bring this coupon for half off. So that's where the 1/2 off of that 28x plus 15. All right. Thank you so very much. All right. So we've got two equations. Okay. The first one is an easy, nice, clean clue. So I'm going to go into the other one and I'm going to put parentheses around the y, right? And I'm going to substitute 14x into the other equation where there was a y. So when you write all of that out, that's where you get this. Y equals, and I substituted 14x from the first equation, equals the second equation. Now you have to distribute, right? So half of 28x is 14x, and half of 15 is 7.5. That's the distribution step. Now I want to get, before I can solve for x, do I have to get them all on the same side of the equation? I do, right? I have to have them all on the left or all on the right in order to solve for them. So if I've already got 14x over here, I'm going to minus 14x over here, and I want the x's off of this side and over to here. But something kind of unique happens. When I have 14x minus 14x, those zero out, leaving me 0. And then over here, I'm left with 750. Well, all my variables disappeared. Everything zeroed out, and I'm left with 0 equals 750. Does 0 equal 750? So what kind of solution is this? Is there ever a point where they will cost the same? This is a no solution. If in all of your substitution work, if you are solving for that first substitution and you end up with this very unique where your X's or your R's or your P's or whatever, where they completely zero out and go away and you don't have any more X's to solve for, then it's a special case. It's either no solution or it's infinite. Okay. And in this case, because 0 does not equal 750, it's no solution. So now, keeping that in mind, right? If you look at example 3, they gave us two equations. They gave us this blue one right here, and they gave us this purple one right here. And they chose the blue one right here to get x by itself. Now notice I add, they kind of skip this step, but I'm going to show you where they get it. They add 2y and they add 2y, right? Negative x drops down, negative 8491 drops down, and we added 2y. That's how we get to this step. But am I actually solved for x here? It's got a negative in front of it. So really that's a -1. So in order to really truly get x by itself, it can't even have a negative sign with it. I have to divide by -1, divide by -1, and divide by -1. In doing that, that gets rid of that negative, and I'm truly left with x by itself. And notice it changes the -84 to positive and the positive 2y to negative. This is solved for x. Okay, you have to get that negative off there if need be. Now, that becomes our clue, right? We solve for x. That becomes our clue. We go to the other equation, which this was our purple one. And where there's an x, we're going to put parentheses. So what they've done here is, this was the x right here. 3x minus 6y equals 254.73. And they have substituted the clue 84.91 minus 2y in for the x. And now you distribute. Okay. 3 times 84.91 is 254.73. And 3 times -2y is positive 6 or -6y. Now, if I want to combine like terms, what is 6y minus 6y? What's 6 apples minus 6 apples? How many apples do you have left? 0. They zero out again. What are you left with? This 254.73 drops down. This 254.73 drops down. It's another special case because your variables zeroed out. They went away. They're gone. But is it a no solution like here where 0 does not equal 750? So it's no solution. Or you've got two identical terms equaling each other, which means it's what? Infinitely many. So when you're solving by substitution, the reason we did our jump start this morning was to remind ourselves the 3 possible outcomes. One solution where you have an x and a y, or an a and a c, or a p and an r, or whatever. No solution, or infinitely many. When you're solving by substitution, all 3 of those are still valid options. You're either going to get one solution where you get a value for the x and the y, or for the a and the p, or whatever, or you're going to get no solution where your variables zero out and they're gone and you have a not true statement, or you're going to have infinitely many where your variables zero out, they're gone, and you're left with a true statement. Okay, so if you want to make yourself a little reminder here, and this is totally up to you, okay, if you get a number for your first variable, keep going, okay, because that means it's going to be a one solution, okay. If your variable, I'll show first variable because it's in that first step that you're doing it. If your first variable zeroes out, okay, it's either no solution or it's infinitely many. Okay, if it's no solution, you're going to get something like 0 equals 8. Not true. If it's infinitely many, you're going to get something like 8 equals 8. Okay. All right. For your homework, I'm actually not going to give you homework on the no solution and infinitely many because my other classes, I did not get through the notes of the no solution and infinitely many part. So I didn't give them homework on it. So I want to give you the same number of homework problems. And then tomorrow I'll get you caught up. So for today, real quick, for today's homework, circle them or look online. You're going to do 7, 10, and 11. Okay, 7, 10, and 11. You guys have a fabulous day. For those of you at home, if you get stuck, you can either email me or come see me during advisory when you get back to school.